Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Your infrastructure includes a set of YouTube channels. You have been tasked with creating a process for sending the YouTube channel data to Google Cloud for analysis. You want to design a solution that allows your worldwide marketing teams to perform ANSI SQL and other types of analysis on up-to-date YouTube channels' log data. How should you set up the log data transfer into Google Cloud? The options are: Option A, use storage transfer service to transfer the offsite backup files to a cloud storage multi-regional storage bucket as a final destination. Option B, use storage transfer service to transfer the offsite backup files to a cloud storage regional bucket as a final destination. Option C, use BigQuery data transfer service to transfer the offsite backup files to a cloud storage multi-regional storage bucket as a final destination. Option D, use BigQuery data transfer service to transfer the offsite backup files to a cloud storage regional storage bucket as a final destination.
To arrive at the correct answer, we focus on the keywords: YouTube channel data, worldwide marketing teams, ANSI SQL.
The correct answer is option C. Use BigQuery data transfer service to transfer the offsite backup files to a cloud storage multi-regional storage bucket as a final destination.
Why is this correct? C. BigQuery data transfer service natively supports transferring YouTube channel data for ANSI SQL analysis. A multi-regional storage bucket ensures optimal access and availability for worldwide marketing teams. Why are the others incorrect? A. Storage transfer service is designed for moving data between storage systems, not for natively ingesting YouTube channel data for ANSI SQL analysis. B. Storage transfer service lacks native YouTube integration for this purpose, and a regional bucket is suboptimal for worldwide marketing teams. D. Although it uses the correct transfer service, a regional bucket does not provide the broad global availability needed by worldwide marketing teams.
You are designing storage for very large text files for a data pipeline on Google Cloud. You want to support ANSI SQL queries. You also want to support compression and parallel load from the input locations using Google recommended practices. What should you do? The options are: Option A, transform text files to compressed Avro using Cloud Dataflow. Use BigQuery for storage and query. Option B, transform text files to compressed Avro using Cloud Dataflow. Use cloud storage and BigQuery permanent linked tables for query. Option C, compress text files to gzip using the grid computing tools. Use BigQuery for storage and query. Option D, compress text files to gzip using the grid computing tools. Use cloud storage, and then import into Cloud Bigtable for query.
To arrive at the correct answer, we focus on the keywords: very large text files, ANSI SQL queries, compression and parallel load from the input locations, Google recommended practices.
The correct answer is option B. Transform text files to compressed Avro using Cloud Dataflow. Use cloud storage and BigQuery permanent linked tables for query.
Why is this correct? B. Avro format is splittable even when compressed, enabling highly efficient parallel processing. Using BigQuery permanent linked tables over cloud storage allows you to execute ANSI SQL queries directly from the input locations without moving the data. Why are the others incorrect? A. Storing data in native BigQuery storage moves the data away from cloud storage, failing the requirement to load and query directly from the input locations. C. Grid computing tools are not a Google Cloud recommended practice. Furthermore, gzip compression is not splittable, which severely limits parallel processing capabilities. D. Cloud Bigtable is a NoSQL database and does not natively support ANSI SQL queries. Also, grid computing tools are not a Google Cloud recommended practice.
You are developing an application on Google Cloud that will automatically generate subject labels for users' blog posts. You are under competitive pressure to add this feature quickly, and you have no additional developer resources. No one on your team has experience with machine learning. What should you do? The options are: Option A, call the Cloud Natural Language API from your application. Process the generated entity analysis as labels. Option B, call the Cloud Natural Language API from your application. Process the generated sentiment analysis as labels. Option C, build and train a text classification model using TensorFlow. Deploy the model using Cloud Machine Learning Engine. Call the model from your application and process the results as labels. Option D, build and train a text classification model using TensorFlow. Deploy the model using a Kubernetes engine cluster. Call the model from your application and process the results as labels.
To arrive at the correct answer, we focus on the keywords, generate subject labels, add this feature quickly, no additional developer resources, no one on your team has experience with machine learning.
The correct answer is option A, call the Cloud Natural Language API from your application. Process the generated entity analysis as labels.
Why is this correct? A. The Cloud Natural Language API provides pre-trained models for tasks like entity analysis, which extracts subjects from text. This requires no machine learning experience and can be implemented quickly. Why are the others incorrect? B. Sentiment analysis determines the overall emotional polarity, positive or negative, of the text, but it does not identify or generate subject labels. C. Building and training a custom text classification model with TensorFlow requires significant machine learning expertise and development time, contradicting the team's constraints. D. Creating a custom TensorFlow model demands machine learning experience and additional development time, violating the constraints of needing a quick implementation without ML expertise.
You are designing storage for 20 terabytes of text files as part of deploying a data pipeline on Google Cloud. Your input data is in CSV format. You want to minimize the cost of querying aggregate values for multiple users who will query the data in cloud storage with multiple engines. Which storage service and schema design should you use? The options are: Option A, use Cloud Bigtable for storage. Install the HBase shell on a compute engine instance to query the Cloud Bigtable data. Option B, use Cloud Bigtable for storage. Link as permanent tables in BigQuery for query. Option C, use cloud storage for storage. Link as permanent tables in BigQuery for query. Option D, use cloud storage for storage. Link as temporary tables in BigQuery for query.
To arrive at the correct answer, we focus on the keywords, 20 terabytes of text files, CSV format, minimize the cost, querying aggregate values, multiple users, multiple engines.
The correct answer is option C, use cloud storage for storage. Link as permanent tables in BigQuery for query.
Why is this correct? C. Cloud storage is a highly cost-effective solution for storing large text files. Linking it as a permanent table in BigQuery enables efficient querying of aggregate values by multiple users. Why are the others incorrect? A. Cloud Bigtable is not cost-effective for storing CSV files and is designed for low-latency transactional workloads, not aggregate analytical queries. B. Cloud Bigtable increases storage costs unnecessarily for CSV files and is not optimized for analytical aggregation queries. D. Temporary tables have a limited lifespan and are restricted to a single session, making them unsuitable for sharing data among multiple users and engines.
You are designing storage for 2 relational tables that are part of a 10 terabytes database on Google Cloud. You want to support transactions that scale horizontally. You also want to optimize data for range queries on non-key columns. What should you do? The options are: Option A, use Cloud SQL for storage. Add secondary indexes to support query patterns. Option B, use Cloud SQL for storage. Use Cloud Dataflow to transform data to support query patterns. Option C, use Cloud Spanner for storage. Add secondary indexes to support query patterns. Option D, use Cloud Spanner for storage. Use Cloud Dataflow to transform data to support query patterns.
To arrive at the correct answer, we focus on the keywords: relational tables, 10 terabytes database, transactions that scale horizontally, optimize data for range queries on non-key columns.
The correct answer is option C, use Cloud Spanner for storage. Add secondary indexes to support query patterns.
Why is this correct? C. Cloud Spanner supports relational tables, horizontally scalable transactions, and easily handles 10 terabytes databases. Adding secondary indexes natively and efficiently optimizes range queries on non-key columns without extra infrastructure. Why are the others incorrect? A. Cloud SQL is a relational database that scales vertically for write transactions, not horizontally, making it unsuitable for this scaling requirement. B. Cloud SQL does not scale horizontally for transactions. Additionally, using Cloud Dataflow to support query patterns is overly complex when native indexes suffice. D. Although Cloud Spanner is the correct storage choice, using Cloud Dataflow to transform data to support range queries is unnecessary overhead since Spanner natively supports secondary indexes.
Your financial services company is moving to cloud technology and wants to store 50 terabytes of financial time series data in the cloud. This data is updated frequently and new data will be streaming in all the time. Your company also wants to move their existing Apache Hadoop jobs to the cloud to get insights into this data. Which product should they use to store the data? The options are: Option A, Cloud Bigtable. Option B, Google BigQuery. Option C, Google Cloud Storage. Option D, Google Cloud Data Store.
To arrive at the correct answer, we focus on the keywords: 50 terabytes, time series data, updated frequently, streaming in all the time, Apache Hadoop jobs.
The correct answer is option A, Cloud Bigtable.
Why is this correct? A. Cloud Bigtable is a NoSQL wide column store designed for massive scale, low latency, and high throughput. It is ideal for heavy read/write workloads like streaming time series data and integrates seamlessly with Apache Hadoop via the HBase API. Why are the others incorrect? B. Google BigQuery is an enterprise data warehouse designed for complex analytical SQL queries, not optimized for low latency, high frequency updates, and continuous streaming time series ingestion. C. Google Cloud Storage is an object storage service. While it works with Hadoop, it is not built for high-frequency transactional updates and continuous low-latency streaming of time series data. D. Google Cloud Data Store is a NoSQL document database suited for structured data in web and mobile applications. It is not designed to handle massive-scale, high-throughput streaming time series data workloads.
An organization maintains a Google BigQuery dataset that contains tables with user-level data. They want to expose aggregates of this data to other Google Cloud projects, while still controlling access to the user-level data. Additionally, they need to minimize their overall storage cost and ensure the analysis cost for other projects is assigned to those projects. What should they do? The options are: Option A, create and share an authorized view that provides the aggregate results. Option B, create and share a new dataset and view that provides the aggregate results. Option C, create and share a new dataset and table that contains the aggregate results. Option D, create data viewer identity and access management (IAM) roles on the dataset to enable sharing.
To arrive at the correct answer, we focus on the keywords: expose aggregates of this data to other Google Cloud projects, controlling access to the user-level data, minimize their overall storage cost, analysis cost for other projects is assigned to those projects.
The correct answer is option A, create and share an authorized view that provides the aggregate results.
Why is this correct? A. An authorized view shares query results without granting access to underlying tables, controlling access to user-level data. As a view, it avoids data duplication, minimizing storage costs. Furthermore, queries against views are billed to the querying project. Why are the others incorrect? B. A standard view requires users to have read access to the underlying dataset. This would expose the user-level data, failing the access control requirement. C. Creating a new table with aggregate results duplicates data, which increases storage overhead and violates the requirement to minimize overall storage cost. D. Granting data viewer IAM roles on the dataset provides direct read access to all tables within it, failing the requirement to control access to the user-level data.
Government regulations in your industry mandate that you have to maintain an auditable record of access to certain types of data. Assuming that all expiring logs will be archived correctly, where should you store data that is subject to that mandate? The options are: Option A, encrypted on cloud storage with user-supplied encryption keys. A separate decryption key will be given to each authorized user. Option B, in a BigQuery dataset that is viewable only by authorized personnel, with the data access log used to provide the auditability. Option C, in Cloud SQL, with separate database usernames to each user. The Cloud SQL admin activity logs will be used to provide the auditability. Option D, in a bucket on cloud storage that is accessible only by an App Engine service that collects user information and logs the access before providing a link to the bucket.
To arrive at the correct answer, we focus on the keywords: maintain an auditable record of access, store data.
The correct answer is option B, in a BigQuery dataset that is viewable only by authorized personnel, with the data access log used to provide the auditability.
Why is this correct? B. BigQuery natively integrates with cloud audit logs to provide data access logs. This securely records who access specific data, efficiently satisfying the regulatory mandate for an auditable record of access without requiring custom infrastructure. Why are the others incorrect? A. While cloud storage supports encryption with user-supplied keys, this focuses on data security at rest, not providing an auditable record of data access. C. Cloud SQL admin activity logs only track administrative actions, like instance creation or deletion, not the individual data access queries executed by users. D. Building a custom App Engine proxy to collect information and log access adds unnecessary architectural complexity and operational overhead compared to using native audit logs.
Your neural network model is taking days to train. You want to increase the training speed. What can you do? The options are: Option A, subsample your test dataset. Option B, subsample your training dataset. Option C, increase the number of input features to your model. Option D, increase the number of layers in your neural network.
To arrive at the correct answer, we focus on the keywords: taking days to train, increase the training speed.
The correct answer is option B, subsample your training dataset.
Why is this correct? B. Subsampling the training dataset reduces the amount of data the model must process per epoch, directly decreasing the overall training time. Why are the others incorrect? A. Subsampling the test dataset only speeds up the evaluation phase, not the model's actual training process. C. Increasing input features adds more data and parameters for the model to process, which slows down training. D. Increasing the number of layers adds complexity and requires more computations, further increasing the training time.
You are responsible for writing your company's ETL pipelines to run on an Apache Hadoop cluster. The pipeline will require some checkpointing and splitting pipelines. Which method should you use to write the pipelines? The options are: Option A, PigLatin using Pig. Option B, HiveQL using Hive. Option C, Java using MapReduce. Option D, Python using MapReduce.
To arrive at the correct answer, we focus on the keywords ETL pipelines, Apache Hadoop cluster, checkpointing, and splitting pipelines.
The correct answer is option A, Pig Latin using Pig.
Why is this correct? A. Apache Pig is a Dataflow language ideal for ETL on Hadoop. It supports multi-query execution for splitting pipelines and allows storing intermediate results, which easily facilitates checkpointing complex workflows. Why are the others incorrect? B. Hive is designed for data warehousing and ad hoc SQL queries on structured data, making it less suitable than Pig for writing complex, split-flow ETL pipelines with manual checkpointing. C. Java MapReduce is a low-level framework. Implementing multi-step ETL pipelines with splitting and checkpointing requires writing extensive, complex, and difficult-to-maintain boilerplate code. D. Python MapReduce via streaming is similarly low-level. It lacks the built-in abstractions for data flows, splitting pipelines, and checkpointing provided by Pig Latin.
Your company maintains a hybrid deployment with GCP, where analytics are performed on your anonymized customer data. The data are imported to cloud storage from your data center through parallel uploads to a data transfer server running on GCP. Management informs you that the daily transfers take too long and have asked you to fix the problem. You want to maximize transfer speeds. Which action should you take? The options are: Option A, increase the CPU size on your server. Option B, increase the size of the Google persistent disk on your server. Option C, increase your network bandwidth from your data center to GCP. Option D, increase your network bandwidth from compute engine to cloud storage.
To arrive at the correct answer, we focus on the keywords imported to cloud storage from your data center, daily transfers take too long, maximize transfer speeds.
The correct answer is option C, increase your network bandwidth from your data center to GCP.
Why is this correct? C. The primary bottleneck in moving data from an on-premises data center to GCP is typically the external network connection. Increasing bandwidth directly addresses the long transfer times over this hybrid link. Why are the others incorrect? A. Increasing CPU size on the transfer server does not address the main bottleneck, which is the network bandwidth between the data center and GCP. B. The data transfer server writes to cloud storage, not its local persistent disk. Increasing the disk size will not improve network throughput. D. The connection between compute engine and cloud storage within GCP already has very high bandwidth. The real bottleneck is the external link from the data center.
After migrating ETL jobs to run on BigQuery, you need to verify that the output of the migrated jobs is the same as the output of the original. You've loaded a table containing the output of the original job and want to compare the contents with output from the migrated job to show that they are identical. The tables do not contain a primary key column that would enable you to join them together for comparison. What should you do? The options are: Option A, select random samples from the tables using the rand function and compare the samples. Option B, select random samples from the tables using the hash function and compare the samples. Option C, use a Dataproc cluster and the BigQuery Hadoop connector to read the data from each table and calculate a hash from non-timestamp columns of the table after sorting. Compare the hashes of each table. Option D, create stratified random samples using the over function and compare equivalent samples from each table.
To arrive at the correct answer, we focus on the keywords, verify that the output of the migrated jobs is the same, compare the contents, do not contain a primary key column.
The correct answer is option C, use a Dataproc cluster and the BigQuery Hadoop connector to read the data from each table and calculate a hash from non-timestamp columns of the table after sorting. Compare the hashes of each table.
Why is this correct? C. Without a primary key, a direct join is impossible. Sorting and calculating a hash on non-timestamp columns across the entire dataset provides a reliable way to compare the complete contents of both tables for exact equality. Why are the others incorrect? A. Random sampling only compares a subset of the data, which is insufficient to guarantee that the entire tables are completely identical. B. Hashing random samples still only evaluates a subset of the data, failing to prove that the full contents of both tables match exactly. D. Stratified random sampling is a statistical method that compares subsets of data, not the complete table contents required to verify identical output.
You are a head of BI at a large enterprise company with multiple business units that each have different priorities and budgets. You use on-demand pricing for BigQuery with a quota of 2K concurrent on-demand slots per project. Users at your organization sometimes don't get slots to execute their query, and you need to correct this. You'd like to avoid introducing new projects to your account. What should you do? The options are: Option A, convert your batch BQ queries into interactive BQ queries. Option B, create an additional project to overcome the 2K on-demand per project quota. Option C, switch to flat rate pricing and establish a hierarchical priority model for your projects. Option D, increase the amount of concurrent slots per project at the quotas page at the Cloud Console.
To arrive at the correct answer, we focus on the keywords, multiple business units that each have different priorities and budgets, on-demand pricing for BigQuery, quota of 2K concurrent on-demand slots, don't get slots to execute their query, avoid introducing new projects.
The correct answer is option C, switch to flat rate pricing and establish a hierarchical priority model for your projects.
Why is this correct? C. Flat rate pricing, capacity pricing, lets you purchase a dedicated pool of slots. By establishing a hierarchical priority model using reservations, you can allocate these slots according to business unit priorities and budgets, bypassing the on-demand quota without needing new projects. Why are the others incorrect? A. Converting to interactive queries does not increase the overall slot capacity. Both batch and interactive queries are subject to the same on-demand limits, so this will not resolve the slot shortage. B. The scenario explicitly states that you want to avoid introducing new projects to your account. Creating an additional project directly violates this requirement. D. The 2,000 concurrent slots per project limit for on-demand pricing in BigQuery is a hard limit and cannot be increased through the Cloud Console quotas page.
You have an Apache Kafka cluster on-prem with topics containing web application logs. You need to replicate the data to Google Cloud for analysis in BigQuery and cloud storage. The preferred replication method is mirroring to avoid deployment of Kafka Connect plugins. What should you do? The options are: Option A, deploy a Kafka cluster on GCE VM instances. Configure your on-prem cluster to mirror your topics to the cluster running in GCE. Use a Dataproc cluster or Dataflow job to read from Kafka and write to GCS. Option B, deploy a Kafka cluster on GCE VM instances with the pub/sub Kafka connector configured as a sync connector. Use a Dataproc cluster or Dataflow job to read from Kafka and write to GCS. Option C, deploy the pub/sub Kafka connector to your on-prem Kafka cluster and configure pub/sub as a source connector. Use a Dataflow job to read from pub/sub and write to GCS. Option D, deploy the pub/sub Kafka connector to your on-prem Kafka cluster and configure pub/sub as a sync connector. Use a Dataflow job to read from pub/sub and write to GCS.
To arrive at the correct answer, we focus on the keywords, Apache Kafka cluster on-prem, replicate the data to Google Cloud, mirroring to avoid deployment of Kafka Connect plugins.
The correct answer is option A, deploy a Kafka cluster on GCE VM instances. Configure your on-prem cluster to mirror your topics to the cluster running in GCE. Use a Dataproc cluster or Dataflow job to read from Kafka and write to GCS.
Why is this correct? A. Deploying a Kafka cluster on GCE and configuring the on-prem cluster to mirror to it avoids deploying Kafka Connect plugins on-prem, perfectly fulfilling the core requirement. Why are the others incorrect? B. This approach involves deploying a pub/sub Kafka connector, which contradicts the explicit requirement to avoid deploying Kafka Connect plugins. C. This solution requires deploying the pub/sub Kafka connector to the on-prem cluster, directly violating the requirement to avoid Kafka Connect plugins. D. Deploying the pub/sub Kafka connector to the on-prem cluster directly violates the stated constraint to avoid deploying Kafka Connect plugins.
You've migrated a Hadoop job from an on-prem cluster to Dataproc and GCS. Your Spark job is a complicated analytical workload that consists of many shuffling operations, and initial data are Parquet files, on average 200 to 400 megabytes size each. You see some degradation in performance after the migration to Dataproc, so you'd like to optimize for it. You need to keep in mind that your organization is very cost-sensitive, so you'd like to continue using Dataproc on preemptibles, with 2 non-preemptible workers only, for this workload. What should you do? The options are: Option A, increase the size of your Parquet files to ensure them to be 1 GB minimum. Option B, switch to TF records formats, APPR. 200 megabytes per file, instead of Parquet files. Option C, switch from HDDs to SSDs, copy initial data from GCS to HDFS, run the Spark job and copy results back to GCS. Option D, switch from HDDs to SSDs, override the preemptible VM's configuration to increase the boot disk size.
To arrive at the correct answer, we focus on the keywords: many shuffling operations, degradation in performance, cost-sensitive, Dataproc on preemptibles.
The correct answer is option D, switch from HDDs to SSDs, override the preemptible VM's configuration to increase the boot disk size.
Why is this correct? D. Switching to SSDs provides higher IOPS for heavy shuffling. Since preemptible VMs store shuffle data on their boot disks by default, increasing the boot disk size provides higher IOPS limits and more space for shuffle data, effectively improving performance while maintaining cost efficiency. Why are the others incorrect? A. Parquet files of 200 to 400 megabytes are optimally sized for Spark. Increasing the file size to 1 GB minimum would reduce processing parallelism and could further degrade performance. B. TF records format is designed specifically for TensorFlow machine learning workloads, not standard Spark analytical processing, and changing formats does not resolve the I/O bottleneck caused by shuffling. Why are the others incorrect? C. Copying data from GCS to HDFS before processing increases execution time and storage costs, violating the cost-sensitive requirement and defeating the purpose of Dataproc's decoupled compute and storage architecture.